All right. This is our first video, first notes video for Regents Chemistry. The question that we're asking and answering today is, what is matter? SWBAT means something simple. It means students will be able to. So by the end of this video and these notes that you're taking, you should be able to classify matter using special vocabulary and interpret particle diagrams of those types of matter. So a real essential question is, what is chemistry? It's quite simple. It's the study of matter and energy. That's it, two things. However, when we study matter, we use certain things called different types of notation, or symbols that represent chemicals and particles and all that other type of things. Our focus today is what types of matter that we're going to encounter and how we draw them. Okay, so that's the main focus. We're going to focus on how we draw, using the right notation, the different types of matter. So matter can be split into two categories. On the left, we can see the things that cannot be separated by physical means. And you should write down in there, those are the pure substances. Those are the things that each piece looks identical and the same at the atomic level. Each piece has the exact same composition. It would be like a bag of all green M&Ms. You open the bag, every piece is identical. Now the other side of the thing, on the right-hand side, we're looking at matter that can be separated by physical means. And we call those mixtures. Mixtures are very common. Most bags of candy actually are mixtures. Thinking back to the M&Ms, you open a bag of M&Ms, you can have 4, 5, 6 different colors in there. Each piece is different. So that bag itself is not pure. Okay, so let's move on to the next part of our flow chart here and fill out this in your notes as you go. So we're going to look at the left side of our flow chart again. So we're going to be dealing with the pure substances still. Okay, pure substances. And things that cannot be separated by a chemical means. A chemical means a reaction. Things that cannot be separated by chemical means are called elements. They're the simplest form of matter. An example will be sodium, one atom, and that's monoatomic because there's one atom. Another example will be chlorine, Cl2, two atoms connected together. We call that diatomic. And those can't be separated by standard normal chemical means. You have to do something special. The other type of pure substances that can be separated by a chemical reaction is called a compound or a molecule. This is what we run into in most of our daily lives. We don't usually run into pure elements, but compounds are very, very common. There are two or more different elements combined together, and the example will be common table salt or water. On the right-hand side of your flow chart, again, we go to the things that can be separated. And things that look like they have the same composition all the way through, we call a homogeneous mixture. Homogeneous means uniform throughout with a distinct pattern. An example would be salt water or iced tea. You know there is something that's been mixed in with the water to make it salty or sweet, but you can't actually see those particles. Now, things that can be separated with different composition throughout, meaning like you can see physically there are different things in your mixture, we call those heterogeneous mixtures. It's not uniform throughout. There's no real pattern inside that mixture of the particles. Italian dressing, concrete with the stones in it, soil, chocolate chip cookies, all of those things have a heterogeneous composition, or they're heterogeneous mixtures. Now let's get down to what we really want to do today, which is draw some particle diagrams. So these particle diagrams are for the pure substances. And you can see in this particle diagram on the left-hand side, we have two atoms of one type combined together. And there are no atoms of any other type, so we would call this an element. Okay? And on the right-hand side, we have a particle diagram of what we would call a compound. Now you see there we have a red dot connected to two white dots. That represents the atoms in a compound that are different and how they are connected together. We're going to go look at our mixtures and see what particle diagrams would look like. A mixture on the left-hand side, you can see that it's a mixture of two different elements. Two or more, 2+ elements in this particular mixture. And on the right-hand side, you can see 2 elements and 2 compounds. So 2 elements and 2 compounds as well. This would be more of a heterogeneous mixture on the right, and a homogeneous mixture on the left. Okay. So some practice in relation to this type of problem that you're going to see very often, or maybe you'll be asked to draw these as well. This question is asking which particle represents a mixture, which diagram represents a mixture. So all you really have to do is look and see and remember what these little circles represent. In this case, we have all the same. So is that a mixture? If everything in there is the same, is it a mixture? In this first option, we have atom of one type connected to an atom of another type, but there's no variation, so it's all the same. Is that a mixture? In number 4 here, we have 2 atoms of the same type connected together, but there's no other types in there. If you look, and you're looking for a mixture, looking for the keywords, you're going to see that the only viable option is number 2 in that particular practice. So, in conclusion, I want you to know that you should now be able to do some of the following things. Draw and interpret a particle diagram to show elements, compounds, and mixture. Remember, elements are just one type. A compound might be one atom connected to another atom. You know, you do different colors or different shapes. A mixture is going to be a bunch of different stuff mixed in together. It's not connected or anything to that effect. The key vocabulary terms here, which I've spoken, and you may need to take the time to define from your text or the internet, are element, compound, mixture, homogeneous, and heterogeneous. And now you should also be able to explain what the different types of matter are, because here they are: element, compound, mixture, which is broken down into the homogeneous and heterogeneous types. So thanks for listening. That has been a conclusion to this video. You should now work on the remaining practice problems, as well as any other additional work your teacher has to offer you in class. Thanks for paying attention.